But you are able to see my screen in any case, okay?
Yes, sir. Yes.
So fine. So let me not bother much about that because I have already lost time. So it doesn't matter. What is biostatistics? Biostatistics are the development and application of statistical methods to a wide range of topics in biology. And of course, biological experiments, you know. So it encompasses the design of, which is a very important aspect of the statistical study, design of experiment, which I will try to cover a little bit in this presentation. Design of biological experiments, the connection and the analysis of data from those experiments, and most important part, which I always tell to my any presentation, is that is your interpretation. Because most of the times, thanks to these softwares which are available in wide range and in the market, there are so many softwares available in the market, and they will analyze your data and they will produce an output also, and they will give you a table also, but they will not interpret. So the most important part in my all the presentations, the emphasis is all once you have the data, once you have analyzed the data using certain statistical tools or techniques, how we are going to interpret it, which is more important. Now, nowadays, everybody is talking about, of course, I did not want to use the word COVID, but unfortunately, I have to. And everybody is talking about the clinical trials nowadays, even that these type of technical terms are there in public domain. Even in the media also, you must have seen. So, of course, in this presentation, I am not going to touch, but this is just a passing remark that how statistics is very much helpful in designing the clinical trials. Not only that, what should be the sample size, because that is also a kind of very challenging issue in any kind of experiment, not only in clinical trials. So the application of statistical techniques play a very important role in clinical trials also. Sample size determination is very, very important aspect. And in these trials, there are certain statistical methods to determine it scientifically. This is just, as I told you, it is just a passing remark. I am not going to talk about sample size determination in clinical trials. Just passing remark मैं आपको दे रहा हूँ. There is a whole book, and the title itself is Sample Size in Clinical Trials. So with that passing remark, I just come to the basic steps. Now, so of course, I'm told that there is a mix of the group over here to whom I am addressing. There are students, there are researchers, there are faculties, and so on and so forth. So what are the basic steps in research? In research, actually, what we talk about, anything, everything, even if it is not a research, it starts with a planning. You cannot go ahead just without arbitrarily. So there must be a planning. What do you want to do? So there are various steps in the research. Okay. So there is a planning, which is the first step, and then after the planning, how we are going to proceed, you have to design. This is what in the red font, what I have kept over here. I'm going to cover that part a little bit in more detail if the time allows. So there is a planning, there is a design, there is an execution, then there is once you have executed the experiment, there is a lot of data available, then data is to be processed, because raw data, and if you remember that cartoon also, data as such is not going to tell you anything. Then once the data is processed, we go ahead for the what we call as the data analysis part. And once the data is analyzed, the most important thing is that how are you going to present your data? And most important thing is what is the interpretation of your study and all those things. And finally, if you are into a research, then you are going to definitely publish. You would like to publish, because publication is why so important. Because if you do some research and if it gets published, and it gets published somewhere, or even if it gets published in some very good research journal, that is in public domain. So these are the basic steps in the research. Now, as I mentioned that in statistics or even in biostatistics, you have a data which you have planned the experiment and you have collected the data. Now, most important thing which I would like to share with all of you is that in general, I make always this kind of a statement that if you are dealing with statistical tools and techniques, the statistical tools and techniques are completely decided by the data and the type of the data, because you cannot and you should not apply any tool anywhere, everywhere. So it will, which statistical technique I should apply, that will completely depend upon the nature of the data. So this 1 or 2 slides, I want to give you the basic idea of data types. Because as I just mentioned, the type of data will decide the type of analysis which you can do, because there is a lot of statistical tool available. So many statistical tools are available, and you are what my effort will be in this very small presentation even will be that where to use what. It is not that everywhere, anywhere you are going to find out mean, or everywhere you are going to find out proportion or something like that. So in general, my data can be discrete. Say, what is discrete? Discrete means something which can be count. Count means, say, for example, what is the number of patients in a hospital? And everybody knows because of this, the number of patients are increasing in the number of hospitals. The number of patients are getting more and more. So number of patients is a discrete data. Even if you go for your blood chemistry, like WBC, RBC, or even your hemoglobin and all those things, they are all discrete data. Hemoglobin, nahi, RBC, WBC, heartbeat in a minute or heartbeat in a second. So they are all kind of discrete data. But it is not always that you are going to the discrete data. You are going to get the discrete data only. You can get some other kind of data also. Just as I mentioned that the hemoglobin level, it can be 12.4, it can be 12.5, or it can be anything. So the data can be discrete or the data can be continuous. Continuous means it is something like which is measured continuously. Continuously means you are of course not measuring it every time or on every minute, but it is on a continuous range. So for example, what is your height? Your height cannot be 5 feet and after that you get only the 6 feet height. No, it can be 5 feet 1 inches, 5 feet 2 inches, and so on and so forth. So there is a continuity. So your data can be height, weight, or your glucose level or protein contents of a food. All these things what we talk about is a continuous data. So data can be discrete, data can be continuous. And if the data is discrete or continuous, statistically we call it as a quantitative data. Now, it is not necessary that always you are dealing with quantitative data. Many times the data can be qualitative also. Say, for example, you must have seen or you must be doing many of the biostatistical analysis gender-wise. In that sense, or in that case, actually your data is segregated into just male and female. Or sometimes suppose we are talking about certain region or even certain religion, even say qualitative characteristic can be the color of your eyeballs or the color of your skin when we talk about different skin ethnic groups. And when we conduct a multi-center clinical trials, it is very important. So in that case, what is happening is that we are dealing with a qualitative data. So this is just very quick idea, overview sort of a thing. But the quantitative data, as I mentioned just now, the quantitative data can also be of four types mainly. And this type of data has to be once again classified, because once again, I'll keep on repeating till the presentation that the type of data will decide the type of analysis. So nominal means it is just like a nomenclature. Just like suppose you are collecting the data on different blood groups. So you know that ABO system and you know that there is positive, negative, and of course RH system is there. So you know that that is just a kind of nomenclature, that A plus is A plus, fine. But A plus is greater than B plus, that means there is some order, no. Or suppose your bank account number is something and my bank account number is something, or your mobile number is any digit or my mobile number is any digit. So my mobile number is greater than your mobile number. There is nothing like that. It is just a nominal variable that, okay, this is the mobile number of Mr. So-and-so, or this is the blood group of Mr. So-and-so. So nominal means it is just you are giving a name. That's all. So if the data is nominal, what can be the analysis? That is what my part is. So in my first step, I'm just trying to explain you that what can be the data type. Now, second type of data which you can have is what we call as ordinal. Actually, the word ordinal is coming from the word order. Order means something which you can put in certain order, means either ascending order or descending order of magnitude. Say, for example, you have admitted certain patient, a group of patients, and you are just noting down their condition, that what was the patient's condition yesterday, what is the position today, and what is the condition yesterday after tomorrow, or something like that. So it can be worse, it can be unstaged, or it can be not, it can be something like improved or something like that. Or even you can order your height. of the patients or the height of the athletes or anything, whatever you want. So that in nominal, remember there was no order, but in ordinal variable, some orders are there. So that this is a different data. Now, third one is that what we call as the interval variable. Interval variables are something like how much or how less is the difference. So you cannot say that the difference between 70 to 65 is same as the difference between 95 to 100. So what I mean to say, I'll give you a simple example. See, this is not the scale for comparison. See, everybody is talking about your temperature, body temperature in degree Celsius and degree Fahrenheit. So 38 point, or let me say that 98.3 degree, which is common as a degree Celsius, if it converted to Fahrenheit, it is not 98.5. So if I am talking about an interval that we are talking about, how do you compare? So it is not only permits the comparison of more and less, but it also indicates how much or how less is one reading than the other one. And suppose you are recording the data of a patient, say on 24 hours basis, or just you are recording the data on some time scale, say on circular, this is called circular data. If you are taking, say, right from 6 a.m. in the morning to the 6 a.m. next morning, then such kind of data, or say suppose not only 24 hours, suppose you just collect the data between 2 p.m. to 4 p.m. In that case, such type of data is known as the interval data or circular data. Now, let me tell you, I'm not going to take up, of course, there is a whole discussion of what we call as the circular data. That is different. I'm not going to talk. Then finally, we can have a ratio like. Ratio is just very common data which you are using in your real life situation. In your real life situation means you are using the data which is like almost which you are using everywhere in your most of the real life situation, that your length or height or weight or volume, and just like any numerical measure. So the data ratio scale is the most common data which actually we use. Okay. So this is just in the initial slides, I'm just trying to tell you that what is the basic idea of the data and the different types of data. Once the data has been decided and understood, sorry, that this is the type of data, as I mentioned in my opening slides also, that data does not make any sense as such. So you must have heard that there are two approaches to statistical analysis. What we call is that one is called descriptive statistics and another is what we call as the inferential statistics. Now, descriptive, as the name says, descriptive means something which describes the data. Now, suppose you have collected the data of say 100 patients and sorry, and if you want to know that what was their BMI or something like that. So in that case, what you do, first of all, you have to calculate that what is the average height, what is the average weight, and so on and so forth. And depending upon that, you can find out the BMI. So it all depends upon, again, the objective of the study, that what kind of statistical tool you are going to apply on the data, but completely it will be decided by certain very simple statistics which are very common and very powerful. So for example, everybody has studied about or must have heard about, if not studied, like mean, median and mode. Mean is something like which depends on all the observations. So if you are talking about the mean, say what is the mean birth weight of a newly born child? In that case, what happens is that there may be some low birth weight and there may be some normal birth weight, and there may be some babies who are born with very unusual kind of like very high weight or something like that. And in that case, if you are going to find out the mean, it is not going to give you the correct picture, because suppose one baby is of 2 kilogram, 2.1 kilogram, general is 3 to 4 kilograms, or you convert into pound or whatever. And then there are certain babies who are born with 5 kilos and above. And if you find out the mean, it is not the correct, because I am told that you are all into training program. So I just want to go to my last line. Instead of mean, you should use trimmed mean. Now, what is trimmed mean? Of course, I'll come to median also. The data, suppose example which I have taken is that suppose is the weight of the newly born babies. Now there can be some low birth weight, as I told you. But for that, there is a technical term in statistics what we call as the outlier and inlier. In outlier, probably you might have studied or heard, but I'm pretty sure that most of you might not have heard the word inliers or even outliers. I'm not very sure. So if the data presents inliers or the outliers, or if in my data there are certain values which are very low or which are very high, the computation of mean is not recommended. This is what I wanted to convey. Then, sir, what should I do? Okay, my answer is that you go for trimmed mean. Then there could be a natural question, sir, what is trimmed mean then? No, I'm just not taking any formula deliberately. I'm not going to take any summation xi and all that kahani. But the idea here is that if I'm talking about trimming, you understand what is the literal meaning of the trimming. And trimmed mean says that you leave 5% of the observation from the left and you leave 5% observation on the right. That means all the extreme observations are removed. And even then, if you are finding out the mean, that is called a trimmed mean. So it is not only mean, we can have the idea of trimmed mean. So in general, we calculate mean, but in some special cases, we also go for trimmed mean also. Similarly, if my data can be ordered, most of the times if the data can be ordered, we calculate median, not the mean. Like we talk about average height, then it should not be the mean of the height, because if there is one student or one patient which is very having a small height and one patient having very large height, the problem with mean is that it is highly affected by the fluctuations of the observation. That means the extreme observations affect mean too much because all the values are added. So in that case, median is just a position. Now, what is mode? Mode is just like if you take a sample of 100 patients and if you just try to find out that what is their blood group, and people say that the most of the people in India or most common blood group in India is B positive. So that is called modal value. Modal value means that is just a data or just a value which occurs with highest frequency. So depending upon what type of objective of your study is, you will calculate mean, median, mode, or you can calculate other partition values also, depending upon that what type of objective you are having in your mind. Then sometimes it is not always quantitative. If it is qualitative, then we have to not calculate the mean, we have to calculate the proportion. Say for example, what is the proportion of smokers and non-smokers in the population? There you don't use the word mean, because you want to study that what is the effect of smoking on your heart disease, or what is the effect of smoking, say on your cholesterol or something like that. So in that case, we are talking about proportion. And in biostatistics, I'm not saying that mean, median, mode are not used, but generally we use proportion, rates, and ratios. What is the proportion? How many people are affected by diabetes? How many people are affected by this? So that is just a count, a proportion. It is not average. Remember, rate, you know that infant mortality rate, child mortality rate, and different types of rates we calculate. That is called vital statistics. I'm not going to take you into that. And ratios also are there. We can calculate certain ratio, birth ratio, and like even BMI is also a kind of ratio. So this just describes the data, that what type of analysis I am going to do. This is all descriptive statistics. And the next, in the most important aspect of the descriptive statistics, is that to study about the variability. So we talk about the standard deviation, we talk about variance, we talk about coefficient of variation, and we talk about skewness. This is the word which I wanted to introduce to you. That skewness is something like, I don't know whether you have seen a normal distribution or a normal curve, which is beautiful, like bell-shaped curve. But if you look at a curve which is not having the right side and left side like perfectly equal, and during this COVID period also, you must have studied or you must have seen many research papers or many studies which are saying that flattening of the curve. That means the curve increases and then it stabilizes somewhere and then it starts coming down. So all those properties of the curve, that means how the particular situation is behaving. In that case, actually, we talk about skewness and kurtosis, and which will also help us to decide about whether the data is normal or not. So skewness and kurtosis are another two descriptive statistics which are applied in biostatistics also. So you want to study that for how many days the patients stay in the hospital for a particular disease, and you want to collect the data on that and you want to analyze on that. So in that case, skewness and kurtosis is going to help you. Because most of the biological data are skewed. Skewed means they are not symmetric. Somewhere it is very high, somewhere it is very low, somewhere it is flat or something like that. So in that case, the data which we are collecting in biostatistics are mostly skewed data. Say, what is the data of sex ratio? Everybody knows how many girls per 1,000 boys. That varies even in India from state to state. What is the infant mortality rate? What is the maternal mortality rate? And in that case, if you are trying to find out an average, you should use median. I would like to tell you one thing. In my presentations, I have written something in the different color font, and that too in block capital. That simply means that just like in classroom teaching, if I wanted to emphasize something, I will write on board that in capital or maybe underline. So you should understand that suppose I have written median, then here my emphasis is on the word median. Similarly, here also if I have written trimmed mean, then my emphasis is on mean, trimmed mean. So these are just some of the descriptive statistics which you may be knowing. I'm not saying that I'm telling you anything new, but these are the things which you should be actually, what my effort is that to train you that where to apply what. So this is what I'm telling. Now the next slide, of course, it is a little bit early to put this slide here, but I am just putting this slide over here. This one page or one slide will give you in a tabular form that what kind of statistics you should apply, permissible statistics, descriptive or inferential. Descriptive or inferential means inferential I have not discussed. I will just discuss within 10-15 minutes that whatever we are discussing here is just a descriptive statistics, means we are trying to describe the data, the nature of data. We are not trying to discuss or we are not trying to generalize anything. Generalize means I will discuss what do you mean by generalization and all those things. So the whole idea here is that just now, if you recall, that we have discussed that there are 4 types of data: nominal data, ordinal data, interval data, and the ratio data. These are the characteristics. As I just mentioned, that nominal is just a nominal. Say, for example, all of you know that Sachin Tendulkar used to wear a jersey of number 10, or Pele used to wear a jersey of number 10, right? So that is just an identity. So if the data is nominal, basic characteristic is the number. Common examples are social security number, or even say in India also now we have Aadhaar card. So Aadhaar card number. The other examples can be your brand or store types or something like that. If the data is nominal, I should use percentage or mode. Mode I have already told. Please don't look at this column at the moment. I'll come back to this because this is all last column of the table tells you the statistical techniques which are inferential by nature. So because I have not introduced, so I'm just not going to tell you. But here itself, I'm introducing that what is the basic idea of the descriptive statistics again. Sir, if my data is normal, what should I do? This table says that go for mode. Okay, we'll go for mode or simply find out the percentage. Fine. Now, if the data is ordinal, that it indicates certain position or something like that, or there is some order in the data. I don't know. So in that case, ordering means sometimes you must have seen or you must have conducted the survey that, okay, fine, which analgesic, of course, you have not conducted such kind of study, which analgesic you will prefer. I should not say that analgesic should be taken, but there are so many types of analgesics available in the market. So which should I take? So there may be some preference ranking, there must be some other kind of ordering, or even forget about it. Sometimes you talk about whether we should go for a laparoscopy or whether we should go for the invasion or something like that. So what is your preference? So if the data is having some, okay, no, I am not preferring any kind of invasion. There should not be physical invasion. Whatever you want to do, you do it non-invasive techniques. So, okay, my preference is non-invasive. So what is the analysis which I can do? You should try to find out percentile. I hope all of you must have heard the word percentile, because once you pass your 12th standard, your percentile scores are given. So in that case, you should find out percentile or median. Similarly, you can study this table. I'll share this presentation later on. So these are some of the techniques which are permissible statistics descriptive. As I told, I'll come back to this last column also, but before that, let me tell you about what is inferential technique. Because most of the times in statistics, I'm not saying that the descriptive statistics are not used. Descriptive statistics are very much in use, and most of the biostatistics uh, books you will find a lot of emphasis on percentages and mean, median, mode, and other kind of statistical measures which you can calculate. But there is a lot of emphasis on testing, or there is a not lot of emphasis on what we call as the inferential aspect. And in the inferential aspect, we also try to discuss about the whole population by taking a small sample from that population. Say, for example, I'll give you a very classical example of what we call as the pathological tests. What do you do? If the doctor says that, okay, you go ahead with your blood test, what you just go to a lab, and or the person can come to your home and just he or she makes a small prick. And the researches are on that how minimum blood can be taken to study the whole blood chemistry. Now you have almost 6 to 7 liters of blood in your body, but the characteristic is that blood is homogeneous. It is not that the blood in your leg is different than the blood in your arm. So just being a homogeneous population, just a sample of size 1, I always deliver a lecture that if you have a population which is homogeneous by nature, you just take a sample of size 1, that is enough. You are not supposed to take a sample of size 10, 15, 20, which is again a challenging question that, sir, what should be my sample size? No problem. If the population is homogeneous, even a sample of size 1 is more than sufficient. So from that sample, what are you going to do? From that sample, you are going to say something about the whole population. This idea of going from particular to general is actually inferential aspect. And by nature, statistical inference is inductive. Inductive means if something is happening in one place or something is happening in 1 or 2 units of the population, it is expected that similar kind of behavior will be there in the whole population. Now, this is true when the population is homogeneous. But in real life, it is not that always you are dealing with a population which is homogeneous. Population mostly which you come across is a heterogeneous population. So in that case, okay, we don't depend only on one sample, and that is why sample size determination in all these statistical, biostatistical or clinical trial or any study, even if it is a opinion poll survey, it is very important that what was your sample size. Why? Because on the basis of this sample only, you are going to say something about the whole population. So that forms the basis of what we call as the inferential aspect. So what is inference approach? What is inferential approach? Sorry, this is just I'm going to tell you that statistical inference is inductive by nature. That is what I have just told you. Inductive by nature means what? That is going from sample to the population. Sir, what do you mean by sample? Sample means particular, population means general. Now, okay, I am taking a sample from the population, howsoever scientifically I have determined, there is always a chance of error. So that is what we say that we are going to have some generalization or induction within some probabilistic framework. That is most important because I am not 100% sure. There is some error margin. There is something which I have to control. That is again pure statistical discussion. But then what is inference? Inference is just estimation and testing of hypothesis. And I am sure those who are studying biostatistics or those who are taking any course even in pharmacy or medical or whatsoever it may be your degree, but you are all using testing of hypothesis. You want to test a hypothesis. Now, what is a hypothesis? As such, if you take the concept of hypothesis in general, hypothesis is a kind of assumption. Now, what is that assumption? Okay, sir, my assumption is that the hemoglobin level of the school-going girls in Gujarat state is 9.8. Now, the question is, in Gujarat, we are now approaching to 7 crore. Out of 7 crore, there may be 3 crores female population. Out of 3 crores, suppose I am talking about school going girls, like say from 8th standard, so say 12th standard, and suppose they were facing the problem of anemia. This was actually a study undertaken by the government of Gujarat. And then I don't know whether you have heard the name or not, but there was a popular scheme launched by the government of Gujarat known as Kishori Shakti Yojana. And in that Kishori Shakti Yojana, they used to provide IFA, iron folic acid tablets, to a group of girls to study that whether the hemoglobin level after taking these tablets for 20 days or 21 days has changed or not. This is suppose a real life problem. How I'm going to handle it as a biostatistician? So first of all, I will frame some assumption. I will frame some hypothesis. Okay, what is the hypothesis? The hypothesis is this is the blood group. I mean, you can take anything, not only hemoglobin level. This is the blood group, or then it can be a different kind of approach. But I can talk about this. So I'm just giving one characteristic that if I'm talking about, okay, you want to test not only hemoglobin level, you want to test that, okay, what is the average blood sugar level? Okay, go ahead. So you have a hypothesis. Now that is an assumption. Assumptions are not true or may be true. So how we are going to make that assumption is true or false, or it is correct or incorrect? Sorry. So for that, actually what we do or what we go ahead, it is called a statistical test. So we just talk about what we call as a formal statistical test of hypothesis. And what is the test of hypothesis is simply you have to choose between any two possibilities. Because to every hypothesis, generally which we call as a null hypothesis, one of the possibility, and that the hemoglobin level is 9.8. Suppose that is one of the possibilities. How do you say, sir? I'm not sure. Okay. So there must be another possibility. If it is not 9.8, it can be more than 9.8 or it can be less than 9.8. Or even if, sir, I'm not sure, okay, it is not equal to 9.8. That also example I will take. So one of the possibilities, which is called as the null hypothesis, it is generally symbolized by H0, and there is another hypothesis which is symbolized by H1. So what is a statistical hypothesis test? It is just a process, but that is a scientific process. Scientific, why I'm saying so? Because if suppose the hypothesis of hemoglobin level is 9.8 is accepted, then we accept it for the whole Gujarat state, for example. And the sample is taken only a very small sample compared to 3 crore or 2 crore or something like that. But that is valid. Say all of you must be knowing and watching TV every day that the vaccine has come. And in the phase 3 trial, the vaccine, of course, it's a fairly large number. 80,000 sample size is a very big number. But if you compare 80,000 with 100 crore, it is nothing. But then how are you going to say that this vaccine is going to be effective in the whole population? That is just a real life situation which you are going to have, which you are going to test. So, but the problem many a times what we face is that, okay, it is a process which is completely dependent upon the sample. And if the sample says something else, so there is some chance of error that, okay, it may happen that we commit some error, which I'll tell you just in the next table. But what is the process? The process is we accept H0 or reject H0. Okay, if I'm accepting H0, then definitely I'm rejecting H1. And if I'm rejecting H0, that means definitely I'm accepting H1. These are the two possibilities. But it can happen that in reality, the null hypothesis was true, but the data did not support it. Same way, the null hypothesis was false, but somehow or the other data supported it. So you accepted it. So what is the problem? The problem is just like this. I don't know why this is coming throughout. Anyway, एक minute. I hope you can see my screen. You are able to see my screen? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you. Because I don't know, since my beginning of the, I am getting one small band which says that you are sharing your screen, and there's an option of stop share, and I'm afraid if I put a stop share, it will stop sharing. But this sometimes in my visibility, it is interfering with the slide. That is why I just wanted to make sure कि आपको दिख रहा है या नहीं दिख रहा है.
Yeah, sir, it's coming in between. Once you stop sharing and then again you can share that.
Okay, मैं करता हूँ stop share क्योंकि it is disturbing me.
Yeah.
Okay, stop share कर दिया. Fine. Now can you see my screen?
No, sir.
No, but
No,
because I
sir.
have stopped. हाँ, क्योंकि मैंने stop कर दिया ना.
Yes. Once
minute.
again you can try, sir.
एक मिनट रुको. This is the problem with Zoom, यार. I don't know, somehow or the other it disturbs me. एक मिनट. हाँ, ये कहाँ चले गए? रुको, मैं वापस इस पे आता हूँ, सृष्टि पर. अच्छा, सृष्टि नहीं. What is this? हाँ, ज्वाइन टू मीटिंग है, शेयर स्क्रीन. Oh, it's not going. It is all again there.
It's visible, sir. It's
हाँ?
visible. Now it's visible, sir.
ओके, नहीं विजिबल तो है, लेकिन वो स्टॉप शेयर वाली बैंड अभी भी दिख रही है तुमको?
No, sir. अभी नहीं दिख रहा.
ओके, तो मेरे में ही है. I don't care because I know that what is there in my slide. But what I am afraid is that you should be able to see that anything without any interference.
Yes, sir. Please do slideshow.
हाँ, स्लाइड शो मैं कर देता हूँ. Okay, so now you can see again my screen.
Oh. No, something.
स्क्रीन दिख रही है या नहीं?
No, sir. Some green screen is coming. Black green.
अरे यार, अभी तो इसको मैंने.
Sir, do you have any other application open in the background? It might be hindering with the PPT.
That is, you are correct, my friend, but I have not opened anything except my presentation. Actually, when I went to this, what we call as the full screen mode, आप बता रहे हैं screen black हो गई. I don't know why it is so. अच्छा, रुको, एक बार फिर से करता हूँ. एक बार full screen में F5 से करके देखता हूँ. अब देखिए screen.
जी सर, दिख रहा है.
हाँ, ठीक है. अब रुको, मैं सीधे वापस पहुँचता हूँ. अरे एक मिनट. Now let me not bother about it. What? Now you can see my screen?
Yes, sir. Yes.
Okay. So I hope you are able to see my screen, and on the screen you can see that there is a 2x2 table. It says that status true, status false, and the decisions are like accept null and reject null. Now, if I am accepting a hypothesis which is true, now this is a $1 billion question. Sir, how do you know that it is true? I don't know. I just said that hemoglobin level is 9.8 and that was accepted. That happened in the population also. Good. So whatever you assumed turns out to be the same outcome. That means you are accepting a hypothesis when it is actually correct and you are accepting. So actually you are not committing any kind of error. That is why it is called no error. But it may happen that the decision on the basis of the test which you have used, it says that you accept your null hypothesis, but the status is that the hypothesis was not true. That means, in other words, you have accepted a wrong hypothesis. So in that case, it is called a type 2 error. This is type 1, type 2 is just a nomenclature in statistical inference, but these are very important concepts in testing of hypothesis. What are the other possibilities? We reject a hypothesis when actually it is true. And this is the most important thing, which is what called as the type 1 error. And actually type 1 error is associated with your level of significance. So I'm not very sure, but I'm taking some liberty that you must have heard the word level of significance in testing. If you have done some testing, or even if you have not done some testing, you have gone through some testing approach, then there is something like we reject null hypothesis when the hypothesis is true. That is called a type 1 error. And again, if I reject a hypothesis which is actually false and I have rejected it, then there is no question of error. So if there is no error, I am safe. But the trouble is Either I can have type 1 error or I can have type 2 error, and these are the basic concept of statistical inference, which I wish to tell. Now, in testing of hypothesis, it is said, and it is lot of discussions are there, that sir, which of the error is more serious? Whether it is type 1 error which is more serious, or whether it is the type 2 error which is more serious. So after a long of discussion, because today I don't have that much of the time, I have already lost time, but it is for you just for understanding. If you accept something which is not correct, is of course error, I am not saying, but if you reject something which is true, is more serious. Suppose a patient is suffering from a disease and you say that you are not suffering, then he may die without treatment. That is something like reject H naught when H naught is true, right? So what should I do? Scientifically, what should I do? So scientifically, the approach has been that, okay, you fix the type 1 error at certain level. That means what is the maximum type, what is the maximum error which you can commit. So we say that, okay, 1 out of 900 times, 5 out of 100 times. And that is the logical reasoning of taking your level of significance as 1% or 5%. There is no other way. Of course, now the things have changed, and I'm sure that some of you might have referred to the certain research papers. People are nowadays talking about p-value in a big way. So I'll just introduce a little bit about that also. What is inferential statistics? That I have already told you. But of course, one thing more which I wanted to share with you is that I don't know, but I'm just sharing with you. There is, most of people don't know about it, that there is something like type 3 error. बहुतों ने सुना तक नहीं है, नाम भी नहीं सुना है. But whenever I talk about or I give a talk in the case of biostatistics or other, हाँ एक मिनट हाँ, मैं तुमको 3:30 के बाद, अभी 3:30 तक मेरा प्रेजेंटेशन है, उसके बाद मैं कॉल करता हूँ. और इसको बंद कर देना यार, मेरा हल्ला कर रहा है वैसे. Thank you. I'm sorry. So what I am trying to tell you that type 1, type 2 is very common and most of the people are aware of it. But there is something like type 3 error, which most of the people are not even, they have not heard about it. But as I was telling that this is very, very common in case of medical statistics or biostatistics. I'll give a very simple and common joke or an example. What is the concern? Concern is that all too often our concern with accepting or rejecting a null hypothesis on the false grounds blinds us that ऐसा तो नहीं है जैसे मैंने आपसे कहा कि आपकी H naught आपने जो बना दी, who told you that it is true? And you are saying that reject H naught when H naught is true. So again, I repeat, it's $1 billion question. Who told you that it is true? It may be false itself. You are testing a wrong hypothesis that nobody discusses. This is a very, very challenging task, and everywhere those who are dealing with medical or biostatistics are referring to this kind of thing. And for this, the common joke which they share, and I am also sharing, is that I don't know how to cure your present ailment, but if you follow my advice, you stand a very good chance of getting pneumonia, and I know how to cure that. So I hope you are able to understand the depth of this statement. So this is very, very important. This is, I just wanted to share with you as a passing remark. Another very important thing which I told you is that in testing of hypothesis, when we talk about the most important concept nowadays, even if you research, if you refer to any research paper, not only in medical journals, anywhere, everywhere, they are reporting the p-value, and just on the basis of p-value, they are writing their conclusion, which I mentioned that this is the your most important part will be, how to interpret the results and how to report your final testing of hypothesis or whatever you have. So I don't want to take you into this kind of language and all that. Just remember one thing. A smaller p-value means that there is a stronger evidence in favor of the alternative. That means if the p-value is small, your H naught will be rejected. So that's, now let me tell you, p-value is very important nowadays. Why? Because I told you that in testing of hypothesis, it is a scientific procedure. What is the procedure? Okay, I'm taking liberty, but I hope most of you know that if you perform any test of hypothesis, there are two things which we have to compare. One is what we call as the calculated value, and one is what we call as the tabulated value. And the rule of the thumb is if calculated value is less than the tabulated value, we accept our H naught. And if calculated value is greater than the tabulated value, we reject our H naught. Okay. Now, calculated value is something like which you calculate with the help of the sample which you have collected. That is your experiment. Tabulated value comes from the table. Table means for a given level of significance, which I have just introduced, level of significance is nothing but the probability of type 1 error or the maximum value of the probability of type 1 error. And another parameter which we use there for the tabulated value is the degrees of freedom. Now, very quickly, I'll give you the idea of degrees of freedom is the number of independent variables. That is called the degrees of freedom. So now, tabulated value is fixed in the sense that once you prefix your alpha and once you know that what is your sample size, degrees of freedom depends on that. Going to the table, you can find out that what is the tabulated value. Fine. Now think of a situation where your calculated value comes out to be less than the tabulated value for a particular value of alpha, and you don't want to accept your hypothesis somehow or the other. What is what we call as the statistical corruption? I should not use the word, but I am using, is that simply you change the value of alpha and your table value will change. Once the table value changes, your whole conclusion may change. This is what something one has to be very, very careful about it. And therefore, of late, I will not say that very recently, but almost p value is there in the market for the last 20, 30 years. It is not that just in one day. What is p value? P value is not prefixed, number one. P value is sample generated. That means p value can be obtained with the help of certain formula based on the basis of your sample only. So it is not a table value. And many softwares, whatever software you are using, I don't know, but any software, whatever you are using is generating the p value also. So now p value is not predetermined. P value is also based on the sample. So that is more scientific, that is more acceptable in research, that you are not manipulating alpha. Otherwise, as I just told you, that just by changing alpha, the whole scenario can be changed. That is why, and that is the reason that why p-value has become so important in medical statistics or in biostatistics. So now my suggestion would be that even if you are conducting any test of significance, you should try to report or you should try to find out that what is the p-value. And on the basis of the p-value, this is the line which I am saying. If p-value is less than alpha, we may reject the hypothesis. Of course, if p-value is greater than alpha, we may accept the hypothesis. This is the rule of acceptance or rejection the hypothesis based on p-value. And generally, I ask my students that what about getting a p-value equal to 0? You may be surprised, but in many of the outputs, even if you have run some of the outputs using SPSS or even say any other statistical software, you get a table which generates or which gives you the p-value. And most of the times I have seen people are coming to me crying, sir, p-value 0 हो गई, अब क्या करें? So now you can understand, 0 से छोटा तो कुछ होता नहीं है, right? So you have to decide on the basis of p-value. This is very, very important. Now, I'm talking about test and I'm talking about the type 1 error and I'm talking about type 2 error, type 3 error, and I'm talking about even the p-value. Of course, there may be a question in the mind that, sir, which test you have applied? So some of the tests are very common. You have heard the name like test or any other test. Now, these 4 tests which I have mentioned just now, t-test is very, very popular. In many biostatistics books also you'll find t-test is very popular. T-test is very popular, chi-square test is very popular, even FZ tests are very, very popular tests which we apply in many different type of situations. Now in this presentation, of course, I am sorry I will not be able to tell you that where to apply which test, but definitely I'll try to cover something related to this. The idea here is that if you have a test, then where to apply which test, that is of course a big question. But all these tests, whatever I have mentioned, these four tests, T, chi-square, Fz, they are all called parametric test. Number one. Parametric test, as the name suggests, actually it is related to certain parameter of the population. And if it is related to certain parameter of the population, statistically it is parameter, but in population it is some population characteristic. Say for example, once again, okay, what is anything whatever you want to study. Suppose I want to study that what is the BMI level of the college going students. Fine. So I can test BMI, which is a population characteristic. I can test average height, average weight, average age, or any other kind of study, whatever you want to conduct. So you are discussing certain parameter. Not only, sir, on an average, I want to know that, sir, what is the difference in the height of the students or the height of the patients. So there is some variability. So we're talking about that, okay, what is the average, what is the variation, and so on and so forth, or what is the proportion? Say how many people drink coffee and how many people drink tea. I want to say, and I want to conduct a survey. You cannot say that, sir, every population is divided into two parts only. Like there may be more tea drinkers or there may be more coffee drinkers, or even I want to conduct a survey that how many people eat wheat and how many people eat rice. That is a real population, but that is a characteristic that kitne log, how many people are wheat eaters. That is very common in north side. But if you go to the south side, people are the rice eaters. So what is the proportion? For you, it is a proportion, but for reality, it is just the proportion of say particular characteristic. So whatever it may be, if I am testing any population characteristic, which is actually a parameter, all this testing can be done with the help of the parametric tests. Now, because you are at the research level and in the training workshop, you should understand one thing, that you should not apply any statistical tool or technique without verifying the assumptions under which it is valid. So as I mentioned that these four tests are very, very common and very, very popular in the real life situation, but all these applications of the test come with a condition. And the condition is that, hopefully you might have heard this word, the data comes from a normal population, or we assume that the data is normally distributed. So fine, if the data is normally distributed is the challenge, how I am going to verify or how I am going to know that the data is normally distributed? So there are certain tests for normality. These are 9 to 10 tests which I am giving, 10 tests I am giving you. So before you apply t-test, which is very much based on the normality assumption, of course, later on I'll share you one very strong theoretical research which says that the t-test is robust to the assumption of normality, because it is said that t-test is generally used for the sample size where the sample size is small. But if you have a large sample, you should not use the t-test. And t-test should also be used when the population under study is normal. So there are so many approaches. As I told you in the descriptive inference, that we calculate mean median mode, and there is a property of the normal distribution that in the normal distribution mean median mode are almost same. It is not exactly mathematically, suppose it is 12.8, 12.5, 12.7, we accept it that they are almost same. So for any given data, I can very easily calculate descriptive mean median mode, and that has application here. People generally say that, sir, mean median mode ka kya karenge? So not only that, it helps you to describe the characteristic of the data, that mean median mode is also useful in the inferential approach also. And the first thing itself is that it says that if the data has the mean median mode or these three values are same, that it is a normal distribution. Or you can calculate the skewness and kurtosis of any particular given data, whatever I have, it is given to me, and all these options are available in SPSS. Just in one click, you will get all 7, 8, 9, whatever I have mentioned over here. So another way of getting or testing the normality is what we call as the PP plot and QQ plot. There is another very important, which is very common in biostatistics. Of course, I have not touched upon the diagrammatic representation, but the box and the whisker plots are very, very common. Box and whisker means, just in one sentence, is just like a box and whisker is just like a tail. So if the tail of the box on the left side and the right side are almost equal in the length, then the data is normally distributed. This type of diagrams, I'm not very sure, you must have seen in certain research papers. I have just mentioned the idea of trimmed mean, and I have mentioned 5% trimmed mean. So if we find out the 5% trimmed mean, that is also a test of normality. And of course, by using certain curve fit, we can also find out whether the data is normal or not. There are certain other approaches also. This is actually, I'll not be able to cover, of course, but I'm sharing that Kolmogorov-Smirnov is the name of two persons. And this is also a very famous non-parametric test. Just one line, no problem. I have told you about the parametric test. Same way there is a concept of non-parametric test. Let me tell you why. Because always there is not a parameter. There is some characteristic of the population which you want to study. So for example, is there any association between, or is there any, you must have seen that there are certain things which are transmitted genetically. So is it that something, if your parents are diabetic, you will also be diabetic? So I want to test whether the patients whom I am screening now and their parents were also diabetic. So it is a kind of association. And we want to see whether the parents are diabetic, so the progeny are also diabetic or not. So in that case, there is no parameter. Or suppose if the height of the parent is more, then the height of the progeny is also more. In that case, there is no parameter. Of course, we'll say height, but that is a biological characteristic, genetic characteristic. If the parents are tall, then the progeny may not be dwarf. But everybody knows about that Mendelian experiments. So non-parametric tests are also there. So if you have a sample size which is greater than 100, you can use KS test for normality. If the sample size is less than, we have to use Shapiro-Wilks test. These are all available, but I did not want to give you a kind of plethora or Pandora box that so in 90 minutes what you are going to tell, 90 types of tests, and you will be confused. This is what I just did not want. So anyways, what actually we are doing is something like that we are trying to just give you an overview, kind of. This is just like Delhi Darshan, you are visiting Delhi and you are sitting in a bus, and I'm just showing from the outside that look at, this is India Gate. But I am not going to take you to the India Gate because that will take another lecture or another day. But I'm just telling you that, okay, fine, at least you should know. You have attended one lecture in statistics or biostatistics. So have you heard about test for normality? Yes, sir. Something like that. So anyways, with this remark, I have just mentioned that we can talk about the parametric and non-parametric statistical tests. So in parametric testing of hypothesis, generally we are dealing with certain population characteristics, as I have told you, that it can be mean, proportion, variance, or even if the data is bivariate, we can talk about correlation. Say, what is the correlation between height and weight? But then in that case, you are going from the area of univariate distribution to a bivariate distribution. Not only that, regression. I must tell you, we teach regression for 1 year. I repeat, for 1 year. 1 semester. That means for 6 months. And again, we teach in the PG level also. So regression analysis is again one of the most widely used statistical tool even in biostatistics. But in that case, of course, I'm talking about the data which is collected on more variables. So if the data is single variable, that means only height, weight, you can find out mean, variance, proportion. But if the data is bivariate, I can talk about correlation. As I said, what is the correlation between height and weight? Something like that. Or we can talk about association, whether smoking is associated with gender or not. So in that case, it is not a parameter, it is a qualitative characteristic, but then also we can talk about this. So we can check any kind of hypothetical value. So, but remember one thing again, as I mentioned in the opening remark, that the type of data will decide the type of analysis which you are going to do. So generally, if the data is quantitative, Now you know what is quantitative data. Then we apply parametric test. I'm just giving you a, what should I say, a kind of dividing statement. If the data is quantitative, go for parametric test. If the data is qualitative, go for non-parametric test. Just as a rule of thumb. Because so many tests are there, I must share with you, there are at least 100 statistical tests. You may not have heard even. So no issues. That's not an issue. The idea is that I'm just giving you some broad guideline that where to go, which path to follow. After this, what is your route? Okay, sir, it is parametric testing. That means data is quantitative. So next, when we have a hypothesis, as I told you, the hypothesis can be of different types. The null hypothesis, generally, we try to test whether H naught mu is equal to mu naught. Mu naught is some assumed value. Suppose your average weight of a group of, uh, say, group of subjects is, say, for example, 65 kilograms. And they are put on a diet, for example, and you want to assess whether what is the effect of this diet on their weight, say after 21 days or whatever may be your plan of experiment. So we can have our alternative different type. It is, again, I must tell you, there is no hard and fast rule. It is the experimenter who has to decide about whether the hypothesis is a right tail, left tail, or two tail hypothesis. So in that case, the most important thing is that there is no rule, there is no guiding rule. So, sir, how I will decide? It will come from the problem under consideration. Suppose the health club wants to say, because you know that your weight is such an interesting characteristic that somebody wants to gain weight and somebody wants to lose weight. So you must have seen the hoarding and the advertisements also, gain or lose your weight. Now there is a health club in the city who makes a claim, okay, you join our health program or the diet program and your weight will increase by say 10 kilograms or 15 kilograms. So the increase is something like what you call as the greater than. Now that will tell you that your alternative should be mu greater than mu zero. So it is not arbitrary. I don't know whether you have seen these type of hypotheses or not. These are very common and people never tell that why it is greater than here and why it is less than here and why it is not equal to here. And that is what I am trying to tell you. It is not like arbitrarily I have decided that okay, mu should be greater than mu zero. It depends upon what is the objective of your study and therefore it is an art. Setting up of a hypothesis is an art. This is what you have to be very, very careful. So if my study pertains to the weight gain, it should be greater than. If it says that it is less than, that means I am going to lose my weight after a diet program. So in that case, you should write less than sign. And you know, simple school level mathematics, that if mu is greater than mu zero, that means mu minus mu zero is greater than zero, and greater than zero means you are on the right side, and hence the name right-tailed. In many research papers, you might have referred right tail hypothesis, left tail hypothesis, two tail hypothesis. What is this all? Right. So what is a right tailed hypothesis? Right tailed hypothesis is something which is set up like this. And there may be certain situations where I'm not very much sure that suppose if I give this kind of treatment or this kind of regime somebody follows, the result may be either on either side. That means it can be left side or right side, or I'm not very sure that what kind of outcome I'm going to get out of it. So in that case, this mathematically not equal to sign, actually it includes greater than as well as less than. So why it is so important? Just one word before I move to the next slide. If the hypothesis is right tail or left tail, my level of significance remains level of significance alpha unchanged, means the same. Suppose alpha is 5%, so it is 5%. If it is right tail or left tail. But if it is a two-tailed hypothesis, my alpha becomes alpha by 2. This is the thing which I wanted to convey. Alpha by 2, you know, 0.05 divided by 2 is 0.025. So in that case, what happens? If my alpha changes, my table value will change. That is the catch. And if my table value changes, my whole discussion or my whole conclusion may change. So my dear friends, please be very, very careful about the type of hypothesis, whether it is a left tail or right tail or two tail. And it is not arbitrarily that you are writing a right tail or a left tail hypothesis. That exactly comes from the objective of your study. So that is why I thought I must share with one slide at least where I must give you a word of caution that you should not be very, very careful. I mean, you should not be very liberal about that. Okay, whatever it may be, chalta hai, chal se, badhu chale. No, not like that. I'm sorry. Alternative has to be, because ultimately I tell you one thing, you may be surprised to know or surprised to hear even, experimenter is never interested in the null hypothesis. Experimenter is always interested in the alternative. But what is null and what is alternative? Sir, alternative, as the name suggests, is alternative to null. So whatever null you have set up, alternative will automatically come as per the null hypothesis. So therefore, as I said, it is very, very important that how to set up a null hypothesis, because whatever null you have made, that will decide your alternative. And what is the nature of alternative will decide the level of significance. So now you can see the connection. And that is very important. And that is why inference or inferential aspects in statistics have to be dealt with extreme care. Otherwise, okay, you have done all the efforts, you have done a lot of effort in collection of data and this and that and whatnot, lot of field work, lot of hospital data collection, and then just 30 seconds of calculation will change the whole scenario because you have not taken care of certain very, very important and vital steps. So what do you want? Sir, I want to tell you something like this. In general, if you are talking about hypothesis testing, what kind of hypotheses I can test? Suppose there is only one population under study. Suppose I am conducting some study in Baroda and I want to study certain characteristic of Baroda city, certain population characteristic, whatever it may be. So I am taking only one population under study and I am taking only one sample from that population. So this I am giving you a broad classification. In that case, my testing of hypothesis in statistics, it is known as a one sample problem. Why? Because there is only one population under study and we are interested in some of its characteristics. So if it is a one sample problem, next slide I will tell you which test I should apply. But in general, it is not one sample. Even if I consider and if I restrict only to Baroda city, there are say 30 wards. I can compare one ward with another ward. Then I can take two samples, say ward number 5 and ward number 7. Or even Y ward, I can take one sample from Baroda and another sample from Ahmedabad. So there are two populations and we are taking two sample. In that sense, we use the word two sample. Two sample means I can ask or you can ask, sir, even from the same population, if I take the sample two times, say one sample from Baroda and another sample from Baroda, is it not two sample? No, my dear friend. In that case, it is called a double sample. So be careful whether it is a two sample or whether it is a double sample, they are not the same. So in general, we are just giving you a classification that what type of problems or what type of samples you can get in a population. So we can have one population, one sample, two populations, two sample. So that means suppose I want to compare the average group weight of group of patients in one group and average weight of group of patients in another group. So in that case, this is just a notation. Mu is a notation, it's a Greek letter. It's just a notation that you want to test mu is equal to mu0 or some specified value. And here, suppose I want to test mu1 is equal to mu2. That means whether the average, now you can again, it is not always the weight and height and age or anything. So whatever you want to compare, you are free. You take any characteristic of the population, which is of course quantitative by nature. So sir, can we extend the idea? Why only Ahmedabad, Baroda? Why not Surat, Rajkot and Patan and Bhavnagar and all other states, sorry, all other cities of the Gujarat state? Okay, sir, I am going to generalize. Don't worry. I can take K sample problem. Of course, K का मतलब होता है more than 2 क्योंकि 2 तक तो आपके पास already you have 2 sample problem concept. But suppose I want to compare five cities of Baroda, sorry, 5 cities of Gujarat state. In that case, mu1 is equal to mu2 is equal to, इसीलिए that's why I have left dot dot dot. It depends upon how many populations you want to compare, or how many populations you want to take into your consideration. So in that case, what happens is that my hypothesis changes and I can go to what we call as K sample problem, where K is of course any value greater than 2. So we can have in general like 1 sample, 2 sample, K sample problem. And then what actually we are going to do, which tests you are going to apply. So which test you are going to apply is very, very important thing. That is what you have to understand. So I'm just giving you the list. If it is a univariate data, parametric tests are Z test, T test, F test, or chi-square test. For 1 sample, 2 sample, all these tests will help you. But if it is a K sample problem, none of these tests is going to help you. So in that case, what I'm going to discuss, or what I have to discuss, is that we have to go for the concept of ANOVA. Very, very powerful statistical technique. Most widely used. So what is ANOVA? The full form of ANOVA is analysis of variance. What is BANOVA, sir? You remember, I have told you that my data can be bivariate. And then if you want to apply a bivariate data, ANOVA will not help you. That you have to go to BANOVA. That is called bivariate analysis of variance. Sir, in real life, I am collecting so many characteristics of a patient. So my data becomes multivariate. M stands for multivariate here. So of course, I am just again giving you a very, very passing remark that please do not stop at ANOVA. The word is beyond that. From ANOVA, you go to BANOVA. From BANOVA, you go to MANOVA. So there is something like multivariate analysis of variance. These are all possible. These are just, I am not going to take you to any kind of test, but at least I am telling you the name. Then we have very important concept in biostatistics that several multiple comparisons I have to make. Suppose I am comparing the effectiveness of 3 drugs. Are they same? So first of all, it is a 3 sample problem. So if it is a 3 sample problem, I have to go to ANOVA. And in ANOVA, if the hypothesis is accepted, then there is no problem. That okay, all the 3 or 4 drugs under study or under trial have the same effect. But suppose that H0 is rejected. Then I'm not sure whether these 4 are not equal. Out of these 4, it may happen mu1 is equal to mu2, but mu1 is not equal to mu3. So similarly, I have to compare each analgesic or treatment or drug or whatever pairwise. Say 1 with 2, 1 with 3, 1 with 4. And then again drug number 2 with drug number 3 and drug number 4. That is, in that sense, we call it as a multiple comparison. Multiple comparison, so many comparisons I have to make. And multiple comparisons are made by using what we call as the post hoc analysis. The word post, I hope you understand, means after something. After what? After applying ANOVA only, you come to know that these 5 treatments do not have equal effect. They have a different effect. And if they have a different effect, and I want to know that which of these 2 differ, how I am going to get it. In that case, we go for what we call as the post hoc analysis, or what we call as the post hoc tests. Just again, I can mention, because this is very common, RM stands for a repeated measurement. And this is very, very common in biostatistics. Suppose you are following up a group of patients for 1 year. And suppose these patients are visiting to a doctor every 15 days. So you start with your lipid profile, and after 15 days, you keep on measuring certain pathological parameter. So the patient is same, but on the same patient, you have at least say 10, 15 readings. Or still take simple example. Suppose you are measuring the blood sugar level of a group of patient in 24 hours. You start with FBS, then you go for PPBS2, then you go for RBS at least. All these 3 to aap karte hi hai. So there are 3 readings on the same patient. That type of data is called a repeated measurement data. Repeated measurement means the unit under study is same and we are making multiple or so many measurements on the same. So analysis of RM data is entirely different story. Repeated measurement very common in medical statistics and biostatistics, but the whole analysis changes completely. Of course, I know that there is no time, and I'm sorry that uh, I will not be able to cover all these things with some numerical examples, though I would have, but I don't know in 90 minutes package how much I can give you. So it doesn't matter, no complaint on the timing and no complaint on whatever we have. But whatever we have, I'm just trying to give you just one shot after another shot. And these are the names at least which you should know. And of course, I tell you for each test, for each ANOVA, MANOVA, BANOVA, a separate session you can have or whatever. You can discuss about all those things. I'm not telling about the details, but I'm telling you a real life situation because ultimately remember my key sentence. The type of data will decide the type of statistical tool. So there is a lot of statistical tool available, but the only confusion is where to apply what. And my effort in this presentation was and is in the remaining whatever time I have will be that to train you, to tell you, rather I'm not training, I'm sorry, to tell you that what to use when. Okay. So as I mentioned, the test can be parametric. I am just giving you the name. The test can be non-parametric, and very common non-parametric test is sign test, run test, Wilcoxon sign test, Kruskal-Wallis. This is very, very important. Kruskal-Wallis is again a very important test of ANOVA. And t-test, as I mentioned, which is very, very popular. So sometimes I come across this kind of discussion. Sir, my data is not following normality. Can I apply t-test? Many of the medical students or many of the students, those who are doing PhD in MS University, come to me with their data and discussion. So my submission to them is that t-test is the only test, hopefully. Of course, it is affected by the assumption of normality. But as I told you, there is a very sound theoretical research paper which was published almost 30, 40 years back, which says that t-test is robust. On robustness, you understand what I mean by robust test. So that is why that also makes t-test very, very popular. Even if the data is only of 5 sample or 7 sample, I can apply t-test. But z-test, as I mentioned here, it is known as normal test, and normal means at least your sample size should be more than 30. Now, in many cases, you are not, suppose I have to collect a data on rare disease and there are only 18 patients. So will you make that, okay, another 12 people should get that kind of disease because I have to apply z-test? No, I can go to t-test. So t-test is very, very popular. This is pure biostatistics, which I wanted to share with you. This is called clinical biostatistics. And in clinical biostatistics, we are very much familiar with false positive, false negative. And I hope you must have heard about the words, what we call as the risk ratio, odd ratio, how we are going to reduce the risk. There is another very, very important concept of what we call as NNT, that is called number needed to treat. There is a whole branch of statistics which is called survival analysis. And in survival analysis, two types of estimators are very, very common, or two types of approaches are very, very common. One is Kaplan-Meier estimator and another is Cox regression analysis. I don't know, but I'm taking this liberty of going a little bit higher, maybe at the PG level. But these are, I just wanted to share, once again, I wanted to share at least few names to you. And suppose very important thing is that what we are talking about, as I told you, that regression is a very, very powerful technique. Suppose you are just trying to predict that what is the probability that a person will get a heart disease, say CHD, coronary heart disease, or CAD, anyone. Now, you know, everybody knows, and everybody is talking nowadays even for about, say, COVID research will continue for another 100 years, I tell you. We may not be here, but COVID research will be here. So what is the probability that a person will get a COVID? Or what is the probability that a person will get a CHD? Depending upon, all of you would know the word comorbidity. So suppose I have collected the data on a group of people, those who are having diabetes, those who are having blood pressure, those who are having say family history, those who are smoking, so X1, X2, X3, X4, so on. And now I want to compare or I want to calculate the probability of getting a coronary heart disease. Sir, how I can calculate that? So for that, I'm just sharing with you one word. There is a concept of logistic regression. So we go ahead with the concept of logistic regression. That is a very special type of regression where the dependent variable takes only two values, 0 or 1. That means either you are going to get a heart disease or you are not going to get a heart disease. So in that case, we can apply the concept of logistic regression, and the heading of this slide is statistics which compares the risk. Can you prove it? Those who are smoking will die more compared to those who are non-smokers. In that sense, we calculate the odds ratio, that if a person smokes, what is the chance he will get a heart attack? And if a person does not smoke, what is the chance that he will get a heart attack? So that is called odds ratio. And this odds ratio is calculated with the help of what you call as the concept of logistic regression. Okay, so now what happens is my coordinator Megha is there. Hello.
Yes, sir. Yes.
How much time I am left with?
Sir, now we don't have session, so yeah, you can continue if you want to finish this.
Hello. Okay, you don't have?
Sir, we don't have a next session.
Okay,
So,
you told me yesterday probably, yeah.
yeah.
I mean, I don't know. I have many slides prepared for you, but I don't know how much I can continue because of course, I can keep on speaking and presenting a lot of Pandora's box and all those things there. But maybe just one thing more, and then of course, I would like to stop for my discussions with my participants. So just which is nowadays it is actually very important, and everybody is talking about clinical investigation. So I thought that I must share with you at least 2-3 words, and because now, as I told you, that these type of words are in public domain, thanks to this media coverage and thanks to that interviews with the top leading medical professionals in the country. So statistics which analyzes the clinical investigation, diagnostics and screening, 3, 4, 5 terms at least you should know. What is the sensitivity, what is the specificity, and I have written PPV, that is positive probability value, NPV, negative probability value, sorry, and there is a concept of ROC curve, which is very important in clinical biostatistics, which decides that which diagnostic tool I should use. Say you must have seen, everybody, I am not saying that there are so many competent, there are so many candidate vaccines are available in the world today, even itself. And some of them are leading, not only leading, some of them are performing extremely well because of these two numbers, sensitivity and specificity. You must have seen in the news media also that Covaxin is 95% and Zycovid is 90%. How do you get this 95% and 90%? All those things are coming from sensitivity, specificity, and the concept of ROC curve. ROC is receiver operating characteristic curve, sorry. So this is very important. I am not touching clinical biostatistics because this last slide, of course, I have another 20 slides for you, but I'm sorry, I'm not going to pull on. If you are dealing with a clinical investigation, you must be very careful about these 4-5 terms at least. And finally, when we talk about some inter-rater agreement, like it is very common in case of oncological trials, when we have two raters and you are rating, say, the stage of cancer, right from benign to stage 3 or stage 4, and if you are using, say, as a diagnostic, as a radiology, and in that case, what is the outcome of this test? How much do you agree, or two raters agree, or more than how much two raters agree and yet they do not agree? So there is a concept of what we call as the level of agreement and level of disagreement. So how much do you agree and disagree? It is not like your correlation, like how much is the correlation between height and weight, that concept is given by kappa. So kappa statistics is very important term in diagnostics. Not only kappa, we have the concept of what we call as the weighted kappa statistics also. So in that case, मुकी जाओ प्रकाश, मुकी जाओ तो मैं ये अभी 10-15 मिनट लगेगा मुझे. हाँ तो मैं बुला लेता हूँ आपको. So in that case, what we say is that there is a concept of kappa statistics. This is very common in biostatistics study or biostatistics papers. Fine, I don't know. I am sorry, but I would like to stop here. Though we have no session, but I don't want to just keep on changing my slides and keep on bombarding on you. So many things, so many things. So maybe I would like to stop here. The floor is open for discussion.
So students, you can discuss your queries and if you have any question.
Good evening, sir.
Yes, very good evening.
So Saksham this side. Sir, so you
Pardon?
in between you talked about null hypothesis. So can you give an example that how in a particular scenario we can determine what we should carry out as a null hypothesis?
Yeah, correct. Very true. This is just I gave you the example of that is what is the average height. Okay, let us consider a program. So suppose there is a health club in your city, and they are conducting some weight gain or weight loss or any other kind of program, and they make a claim that okay, you join my health club and you will gain your weight by 10 kilograms. So this is a real life situation. Now you want to, as a researcher, you want to verify their claim. Okay, if you say that you join my health club, you will join, you will lose your gain this weight or something like that. The question is that is it true or not? So in that case, what I will do, I can do one thing. I can go and ask some of those people who have joined this health program, and I can ask, okay, sir, what was your weight before you joined this program? And what is your weight after the program was over? So maybe somebody has gained 2 kilograms, somebody has gained 3 kilograms, somebody has gained 5 kilograms. Now, on the basis of this sample which you have collected, you want to test their claim. So that is the null hypothesis. What is the null hypothesis? Whatever the claim is made by the health club. Now, as an experimenter, you want to check this claim. That is called testing. But because what is the hypothesis? They are saying that, okay, you can lose 10 kilogram, but are we really going to lose 10 kilogram? So that is my hypothesis, that the weight lost or weight gain, whatever, is say 10 kilograms. So that is my null. Alternative, as I told you, the different types will depend upon. If you have joined the health program to lose your weight, it will be less than. If you have joined your health program to gain the weight, it will be greater than. So depending upon your study and depending upon your objective, not only that, suppose I want to study the number of persons who are drinking, say, coffee. So in that case, my hypothesis is not the mean, as I mentioned, it is the proportion. Suppose you conduct a survey on 100 students or 100 people in your city and you just ask, do you drink tea or do you drink coffee? You will get the data T, 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 C, 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 and like that. And suppose you want to test that hypothesis is that 50% people drink coffee and 50% drink tea. So that is my H naught is P is equal to P naught or P is equal to 0.5, something like that. So as I told that setting up of a null hypothesis itself is an art. And there is no formula, my dear friend, that okay, A plus B whole square is A square plus B square plus 2AB. No. Every problem is different. Every problem has certain objective. Every problem has certain setup. And depending on that, you have to specify your null hypothesis.
Okay, sir. Okay. So is it okay to say that if we have a p-value, a greater p-value, then what we supposed as a null hypothesis, that is the true hypothesis. That is the actual scenario.
Right, right, right.
Okay, sir. Thank you very much, sir.
Hello, good afternoon, sir.
Very good afternoon.
Sir,
Your voice is cracking, beta. Your voice is cracking little bit.
statistical analysis on qPCR data.
Your voice is cracking. I am not able to get your voice clear.
Can you write down in the chat box?
No problem. I can just before this student, I could hear him very clearly.
Yes, sir, but I think he has some internet issue. That's
Okay, then no problem.
Yeah.
Then okay, let me go to my chat box.
Nilanshu, can you write down if your internet is not
Or you
stable?
can just try again. You can just try again speaking while if your internet is stable. Hello. Hello. Am I audible?
Yes, sir, you are audible.
Okay, no problem, Mega.
Yeah.
Let the participant, I'm here, no problem. That's why I just wanted to leave actually 10 minutes before, but somehow or the other, on my own, I just kept on going. I need some discussion actually.
हेलो सर
Yes,
सर गुड इवनिंग सर
very good evening.
सर मेरा क्वेश्चन ये है सर जो प्रेजेंट स्लाइड सर दिख रही है स्टैटिक्स विच एनालिसिस क्लिनिकल
हाँ।
इन्वेस्टिगेशन डायग्नोस्टिक एंड स्क्रीनिंग
हाँ।
सो सर मैं स्क्रीनिंग के बारे में जानना चाहता हूँ सपोज सर अगर हम एक दिन में 300 चाइल्ड को हमने स्क्रीनिंग किया
जी।
और देन सर उसमें हमें फाइंड आउट करना है वी हैव टू फाइंड आउट द टोटल द पास एंड फेल and
हाँ।
further total child have to detail evaluation.
हाँ।
So how can be use the which type of the statistics, sir?
स्क्रीनिंग इज एक्चुअली डायग्नोस्टिक एंड स्क्रीनिंग, जैसे मैंने अभी आपसे कहा, इस केस में होता क्या है कि जो मेडिकल वाले ज्यादा बताते हैं स्क्रीनिंग टेस्ट, आप जैसे कहते हैं ना आजकल बहुत चल गया है कि स्क्रीनिंग कर लो। कोविड के टाइम पर, इवन कोविड के पहले आपको पता होगा कि आप स्क्रीनिंग कैसे करते हैं। सो देर आर सर्टेन फिक्स्ड पैरामीटर्स कि आपने मान लीजिए एक कोहर्ट को लिया, जैसे आपने कहा 100 बच्चों को लिया, 1000 बच्चों को लिया, उस केस में आप क्या करेंगे, कोई ना कोई डायग्नोस्टिक तो आपको लगाना ही है। डायग्नोस्टिक का मतलब आप किसी आदमी को देख करके तो नहीं कह देंगे ना कि वो डायबिटिक है या नहीं। तो सबसे इंपॉर्टेंट बात ये होती है कि देयर हैज टू बी वन डायग्नोस्टिक टू दैट, इसीलिए लिखा गया जाता है डायग्नोस्टिक्स एंड स्क्रीनिंग। अब आप टेस्ट करोगे, एक सिंपल टेस्ट डायबिटीज का क्या है सबको पता है, आपका ब्लड शुगर लिया जाएगा, आपकी एक लेवल जांची जाएगी, और अगर आप उस लेवल के हिसाब से अगर आप नॉर्मल रेंज में नहीं आते हैं देन यू आर डिक्लेयर्ड एज ए डायबिटिक पेशेंट। सो अब सवाल ये है कि हो सकता था कि एक पेशेंट डायबिटिक नहीं था और वो डायबिटिक निकल गया, लेकिन ऐसा इस केस में इसलिए नहीं होगा बिकॉज इट इज ए फुल प्रूफ मेथड नाउ। डायग्नोस्टिक विद particular kind of well established diseases are very sure. There is nothing like you are asymptomatic or something like that. So screening comes from pathology, or screening comes from the medical side. Whether that screening is correct or not, that is what we can decide. And that is what you must have heard. मैंने भी आपको भी बताया कि दो टर्म बहुत ज्यादा यूज होते हैं, एक होता है फॉल्स पॉजिटिव और एक ही होता है फॉल्स नेगेटिव। और जैसे आपको ऊपर मैंने एक 2x2 टेबल बताई थी, उसी तरह से 2x2 टेबल में होता है ट्रू पॉजिटिव, ट्रू नेगेटिव, राइट। तो उस केस में क्या होगा, जब फॉल्स पॉजिटिव होता है तो सही नहीं है, और फॉल्स नेगेटिव है वो भी सही नहीं है। तो कैसे पता करें सर कि ये जो मैंने टेस्ट लगाया था, जो डायग्नोसिस की, उसने सही लोगों को क्लासिफाई किया या नहीं। इसीलिए आप आरओसी कर्व की बात करते हैं, और आरओसी कर्व जिस किसी भी डायग्नोस्टिक टूल का आरओसी कर्व 1 की तरफ अप्रोच करता है, वो डायग्नोस्टिक टूल बहुत सही होता है। सही का मतलब एग्जैक्ट होता है, और अगर उस टूल को इस्तेमाल करेंगे तो आपकी जो स्क्रीनिंग होगी वो सही होगी, मतलब वो ट्रू पॉजिटिव ट्रू नेगेटिव पे जाएगी, ना कि फॉल्स पॉजिटिव फॉल्स नेगेटिव।
Okay, sir. Thank you, sir.
नो प्रॉब्लम। Yes. Any other question?
Sir, Nilanshu has written that when performing a statistical analysis on qPCR data,
Which data?
qPCR,
Huh.
where I apply ANOVA on DCT value or fold change. Actually, I didn't get the question even.
Yeah, I'm also not getting the question. Can he join through his voice?
Yes, Nilanshu, can you reframe your question or
Sorry,
you
can you read it once again? Or sorry, can you ask it once
Sir,
again?
it was
Hello.
it is written like when performing, and where should I apply the ANOVA on DCT value or fold changes?
When should I apply ANOVA? Aage?
On DCT value or fold changes, like मैं ANOVA DCT value पे लगाऊं या fold changes पे?
DCT वैल्यू क्या है मैं समझ नहीं पाया.
Actually, Nilanshu, sir, I mean, he will not understand the biological things. I mean, you are questioning about molecular biology, and he
Yeah.
naturally not going to understand those terms, right?
That's correct.
Okay, no issue,
I think
ma'am.
Megha has got my difficulty. See,
Yeah.
I am not a hardcore biologist. Let me tell you. Of course, I'm a biostatistician, so I know certain terms, but I don't know about molecular biology or something like that. But doesn't matter. It is just for me. It is a data and a
Yeah.
characteristic.
Yes.
So let me
Yes,
tell
sir.
you
Yes,
once
sir.
again. If you are dealing with more than 2 types of data, you should go for ANOVA. That will be my reply.
Okay.
If there is only
Okay.
two
Okay.
types of data, or if there is only two population of the data, in that case, any two sample test will help you. But the moment you go ahead from 2 to 3 even, just say for example, I gave you again, say if you want to compare any 3 drugs, whether drug 1, drug 2 or drug 3 are having the same effect or not, in that case you can apply ANOVA. But if it is only I have to compare say drug A with drug B,
Okay.
T test or Z test will help me. I mean, this is how I can reply to your question.
Yes, sir. Yes. Okay, sir.
Okay.
Thank you, sir.
Oh, yeah. Anybody else would like to ask anything? Thanks that we do not have any session beyond after my session. So we can still 10 minutes I can give you. No problem. 5 minutes at least.
Sir, I think, I mean, these are the undergraduate students.
I can understand. Yeah, yeah.
Yeah, sir.
And as you said very rightly that I cannot understand molecular biology, so it will be very difficult for these students to understand hardcore statistics, which I have completely skipped. If you see my slides, I have
Yes.
nowhere I have used even a single formula.
Yes, yes, sir. Because and
Yes,
it's
yes, Megha, please.
that you cannot understand the terminology of molecular biology and some.
No problem. But I can, for me, it is just a data. I
Yeah.
can, as a statistician, I can always help you to analyze the data.
Mm-hmm. Right. Okay, sir. So, sir, these are the undergraduate students. So they must have studied in their curriculum about
No,
basic.
that is very elementary, I tell you. In the name of biostatistics, I am sorry, people are befooling others. They are
Yeah.
not going beyond mean, median, mode. And what I am talking is a hardcore biostatistics, which you will study even in AIMS and ICMR.
Yes, yes, right, sir. So I think they don't have question. The reason is
No problem, no
I
problem.
have seen that when we do some research or when we are in some projects, then only we
Exactly.
used to do a past statistics.
Exactly.
Yeah,
Exactly.
so that's the reason.
No problem. I mean, you are welcome with any kind of your study or data analysis, not even in this workshop. After the workshop, if you are in Gujarat, I am in Baroda, I mean, we can get into touch and we can do something collaborative. I have done all these things for many places, then why not for Gujarat?
Right, sir. Actually, sir, this is hands-on training. This is a residential program for undergraduate students of all over the state, I mean all the states of India,
Okay.
and they are coming from different region.
Okay.
So what we are doing is for 21 days we invite the student for hands-on training and their particular projects on grassroots practices,
Very
which
good.
he has documented since 25 years now.
Oh, great.
So, yeah, so we are part of Honeybee Network, and you have heard about Professor Anil Gupta, maybe.
Yeah,
So,
yeah.
yeah, so
Anil Gupta who was with IIM Ahmedabad.
yes, yes, sir.
Yeah, yeah. I know him.
He is a founder of Srishti, and
Okay.
the two sister institute, that is Gyan and National Innovation Foundation, NIF.
Okay.
So, sir, what we are doing is we invite the students, we train them for 21 days, and at the end of 20 this workshop, I mean 21st day, they have to present their project work they have done, and we choose 10 students out of 50 for 1 lakh rupees grant.
Oh, great.
So this is in collaboration with BIIS, and that time, this time due to pandemic, we have organized this webinar. Otherwise, the whole structure and the mandate of BIIS is different. But due to this pandemic situation, we have started this online courses just to
I
mentor.
can understand. I can
Yeah.
understand. You'll be surprised, Megha. I don't know how could you get my name and how did you contact me. This is the 12th or 13th webinar which I am giving during this pandemic.
Right, sir. Right.
So,
So, sir, we are also facing problem as we invite. You must have seen the schedule that we are inviting.
very huge schedule.
Yeah. Scientists and well-known researchers from the esteemed universities and research labs. So because everything is online, so they also at the moment they postpone the lecture, or maybe they are busy in some meetings and all. So we are also facing that problem. But
No, I can understand.
nice of you, sir. You took out the time. And when the situation improves, we invite the student and they have to perform the projects in the lab, and then maybe we invite you for the session, as you are in the Gujarat. So
Sure. I'll always there for statistics and biostatistics. Always there. No problem.
thank you so much, sir.
Okay. Thank you. So can I leave the meeting now, Megha?
Yes, sir. Yes, sir. Please.
Okay. Thank you.